Well, hello there. How are you? That's fantastic. I just noticed the quality on this camera is less than good. Anyways, today we're going to finish up section 5, which is recognizing argument patterns. We've already learned the 6 different categories of arguments. Now we just have to be able to recognize them, which is really just going to involve representing the argument symbolically and then deciding which category it fits into. Once we know what category it fits into, then we definitely know whether the argument is valid or not. Now, obviously, there are some arguments that won't fit into one of our patterns. And so we've kind of learned how to analyze those, but we'll see one more example of that today. So let me share my camera here. And as always, let's hope that it focuses. That is pretty darn good. Okay, so here we have our 6 different kinds of argument patterns. 4 of them are valid arguments and 2 of them are fallacies. Down here at the bottom of page 22, we have 6 examples, and we're going to represent each example symbolically, and then we'll decide which kind of argument it is. So in example A, we have an if-then. We have a conditional here. So whatever comes after if is going to be my P statement. So robber is fast is P. Whatever comes after then is going to be my Q statement. So police cannot catch him is Q. That means my first premise is if P, then Q, or we can read that as P implies Q. So that's a conditional. See that the next premise, the police cannot catch him. Well, that was Q. That was the Q statement. So my next premise is Q. And then my conclusion, the robber is fast. Well, that was P. All right, so here's my argument represented symbolically. And if I look up here, I notice that P implies Q, and then Q concluding with P looks like this argument pattern here. So this is a fallacy of the converse, which means that this is an invalid argument. I'm not going to write out invalid or valid. I'm not going to write out the name every time because that just makes the video a lot longer. But in your notes, you should go ahead and write that down. So this one is invalid because it fits the pattern of a fallacy of the converse. You can also just kind of think about this argument and realize that it's invalid. The robber is fast, then the police cannot catch him. Premise 2, the police cannot catch him. Well, the only conclusion is not that he's fast. Maybe the police are just bad at chasing people, right? Like there's other things that could be going on there. So it's pretty easy to be able to see that that's an invalid argument, but you need to be able to represent it symbolically, and you need to know that it's called the fallacy of the converse. Okay, going on here to example B, if the pan is hot. So pan is hot is going to be P. Then the beans cook quickly. So beans cook quickly is going to be Q. My first premise then is if P, then Q. So we'll write that as P implies Q. My next premise is the beans do not cook quickly. That's the opposite of Q. So that is the negation of statement Q. Now, my conclusion is the pan is not hot. That is the negation of my P statement. So negation of P. If I fit this into a category, it looks like that's going to be this one right up here where you got P implies Q, not Q, conclusion, not P. That's called modus tollens, and it is a valid argument. So example B is a valid argument, and it would be called a modus tollens. All right, example C. Again, I've got an if-then. So the shoe fits is going to be P. I wear it will be Q. So my first premise is if P, then Q. My next premise is the shoe fits. So that is just my P statement. My conclusion is I wear it is Q. So if we look and see what form that takes, I believe that's the very first one. If P, then Q, second premise P, conclusion Q. Yep, that's the exact format here. So this argument is a valid argument, and it fits into the modus ponens category. Okay, example D. Notice that there is no if-then in this first premise. This is an or statement. So this is a disjunction here. My shoes smell bad is P. We are near a sewage plant is Q. and there's an or joining those. So my first premise is P or Q. The next premise, my shoes do not smell bad. That is the negation of my P statement. So the negation of P, and then my conclusion, we are near a sewage plant. That is statement Q. So let's see, I'm looking for disjunction and then negation of P and Q. And that looks like it's going to be this one right here. Disjunction, negation of P, and then Q. That's exactly what we have. So this argument fits into the disjunctive syllogism category, which makes it a valid argument. Okay, example E, I've got another if then here. So Patrick is potty trained is going to be P. He can sleep over at my house will be Q. So my first premise is if P, then Q. All right. If Patrick sleeps at my house, that's Q. And notice that I've got another if then here. So I'm going to have another conditional. The first part of it is Patrick sleeps at my house. That was Q. He can sleep over at my house. So now I've got Q implies, look, I will play with him. We haven't seen I will play with him yet. That's going to be R. So let's call that one R. Now my conclusion is another conditional. I have another if then here. So I've got another conditional for my conclusion. Patrick is potty trained. That was P. And then I will play with him. Well, we just called that R. Okay. So P implies Q, Q implies R, conclusion, P implies R. And I think you'll notice that that is the exact form for reasoning by transitivity. So again, this is another valid argument form. This is a valid argument and it fits into the reasoning by transitivity category. Finally, example F here, I've got an if then, so I'll have a conditional for my first premise. I eat at Dunkin' Donuts will be P. I will get fat will be Q. So P implies Q is my first premise. Next premise, I don't eat Dunkin' Donuts every day. So that would be the opposite of our P statement. So we'll do negation of P. My conclusion, I will not get fat. So that's the opposite of Q. So we'll do negation of Q. So P implies Q, not P, not Q. That looks like it's the fallacy of the inverse. So this is an invalid argument and is classified as a fallacy of the inverse. Okay, so really what's going on here is that since we have these categories and we know certain arguments that are always valid and certain arguments that are always invalid, we don't necessarily have to do what we did before, where we do this whole truth table every time that we want to decide if an argument is valid or invalid. If we can determine that it fits one of our argument types here, then we know it's either valid or invalid. However, not every argument in the world is going to fit one of these categories. For example, on page 23, we have an argument here that does not fit one of those categories. And so when that happens, we just have to go back to the way that we evaluate any argument, which is to do a truth table that the last column in the truth table will be the conjunction of the premises implies the conclusion. So I always start by doing what we did in the last video, which is to take our argument here and write it as a conditional statement. And so for that conditional statement, we start with the first premise and we want the conjunction of that with the second premise. So here's first premise, conjunction, second premise. This is the conjunction of the premises, and we want this to imply our conclusion, which is not P or not R. Okay, and so this is going to be the last column of our truth table. So I'm going to set up my columns here in my truth table so that this will end up being the last one. So I'm going to make my way from left to right. I've got P implies R. I have a P column. I have an R column. So I can go ahead and have a P implies R column. Okay, then I have a conjunction and I have a column for what's on the left side of the conjunction, but I need a column for what's on the right side of the conjunction. So I need an R implies P column. So we'll do that. R implies P. We'll have a column for that one. Now I'm ready to do this conjunction because I have a column for this and I have a column for this. So I can do the conjunction of the two. So we'll do P implies R, which I've got that column here, and which is the conjunction, and then R implies P. Okay, there's that column. Okay, now the next thing I need is to be able to do this conditional, and I have the whole left side of the conditional taken care of right now, but I don't have my right side of the conditional. So I'm going to need a not P and a not R. So not P, we have that column, and we have a not R column. And now I can do the disjunction of those two. So I can do not P or not R. Now, if I had more room, I would take this whole thing and rewrite it as the column header of the last column, but I don't. So I'm just going to say this column here is supposed to be that whole conditional statement. Okay, now it's just about going through and filling out your trues and falses. So you just have to know your true false rules here. For instance, P implies R is always true except for when P is true and R is false. So if P happens and R doesn't, so P is true and R is false, that's the only time our conditional is false. Every other time it's true. Now we just do this backwards. R implies P. So I'm looking at R first and then P. So true implies true is true. False implies true is true. True implies false is false. False implies false is true. If you had trouble following that, you need to go back and look at the lesson on conditional statements again. Okay, now that I have these two parentheses, I'm now ready to do the conjunction of those, which is an and statement. And the rule for and is only true if both are true. So right off the bat, both of these are true. So I can say this is true. These are not both true, so I have to put false. Not both true, so I have to put false. Here, they're both true again, so I say true. Okay, not P, I'm going to go down. P says true, true, false, false. So we'll change that to false, false, true, true. It's just the opposite. Now I want the opposite of the R column. So true, false, true, false. We'll switch those and it'll go false, true, false, true. Now I want the disjunction of those two columns. The disjunction rule is only false when both are false. So here, they're both false, so I can say this is false. Here, they're not both false, so I have to write true, not both false, so true, not both false, so true. Okay, finally, in our last column, we're doing another conditional here, and we're going to be doing the conditional of the conjunction of the premises. So this column here, it's conditional, not conjunction. I'm not sure what I said. The conditional with this column as the first part of the conditional, and the second part of the conditional is this column. Okay, so I'm going back to my conditional rules now. So true implies false is false as a conditional. Anytime the first part of your conditional is false, the conditional will be true. Here again, if I start with a false, the conditional is true. And here I have true implies true, so that will be true. This argument ultimately is invalid because we did not get a tautology. I have a false here in this last column, which makes this argument invalid. Okay, so sometimes that's just what you got to do if the argument does not fit one of your categories. We've got one more section to go, and it's a relatively easy one. I